From Ansys' side or from Qfunsoft, we've got regular monthly webinar sessions now where we're trying to engage and keep in touch with all our customers during this pandemic time. So thanks for attending. Today, we want to discuss a bit more about how Ansys see digital transformation and how we, from our side, would like to educate or help the engineering industry to adapt to what's happening in the industry, and also with regards to how we can help you with the training facilities on campus, perhaps. So from my side, I'm Laura van Niekerk. I'm working for Qfunsoft. I'm responsible for the Western Cape area. And today we've got Dr. Evan Smits, who will be taking over the presentation, where we will be focusing specifically on a discovery product, one of the Ansys Discovery products that we want to introduce you all to. So Evan, over to you. Thank you very much.
Great, thanks, Laura. Thank you for that introduction and welcome everyone. Thanks for giving up some of your time this afternoon to join us. Hopefully we'll learn something that'll be useful and helpful to you guys. Right, so basically I think my screen has stopped sharing, sorry about that. There we go. Okay, so what we want to look at today is what is something that is on offer from Ansys for the academic program, looking at not only just the software, but also the some sort of learning materials that are available to you, as well as just give you a bit of an introduction to a new, or not a new product, but something that might be of interest to you guys with Ansys Discovery. Okay, so we'll start off with a quick introduction, a bit of an overview of Qfunsoft as well as Ansys for those of you not too familiar with us, and then we'll have a look at Ansys Discovery and see what that product has to offer, and then we'll end off after the demo. We'll end off with having a look at some of the different offerings from Ansys specifically aimed at academic institutions. All right, so from us at Qfunsoft, we've been around for many years now. We are the, well, we call ourselves the leading computer-aided software supplier within the Southern Africa region. We have offices, or the head offices in Pretoria, and Laura and myself are based in the Western Cape to service that region. We are the certified resellers of Ansys product range, so the full product range, so everything from CFD, FEA, even the electromagnetic products. We also resell a product called Rocky, which is a discrete element modeling package. And I just realized this morning we also recently became the resellers of CF Turbo, which is a turbo machinery design package, so that should actually be added here. And then in addition to reselling all these packages, we also offer design and simulation consulting jobs for those clients that don't actually have access to the software and maybe don't use it as frequently. So I don't want to get too much into the marketing side of Ansys, but just to give you guys a bit of a background as to where they are and what their thinking is at the moment. So in all the many different sort of engineering industries and disciplines around that are available, we have a lot of partnerships with large clients in these different areas. So these are obviously some of the major logos that we have associated with us, but obviously there's many, many more. And you can see we cover quite a wide, diverse range from, you know, the aerospace, defense, oil and gas, telecommunications, and there's quite also a large development in biomedical and automotive engineering as well. Okay, and sorry. And so with that sort of quite a wide-ranging customer base, we find that, you know, Ansys has really tried to focus themselves as the simulation experts, focusing purely on simulation software, not really getting too distracted with other types of software. And so they find that they can offer a really focused offering, and in some ways very unique, because it allows them to draw together a lot of different packages. So the whole idea with Ansys is it's about creating this sort of unified platform where we can bring together all the different simulation softwares into this sort of multi-physics approach, as they call it, and just allowing people to be more accurate, and also gain great insight into their products. So with every platform, or with every sort of simulation, obviously material selection is quite a large part of that. So we do offer quite an extensive range of materials database within our offering. And I'll talk a bit about that later as well. And then obviously with that, we bring in all the different kind of physics streams that we have on offer. So the traditional ones like the fluids and the structural analysis, but also areas that have been growing over the last few years, particularly electromagnetics, as well as semiconductors, embedded software, as well as optical packages as well. So not only is there growth in those individual streams, but it's also about how we bring all these packages together and integrate them into some sort of unified system. And then also, apart from the software side of things, how Ansys sees itself in terms of engineering and the design cycle, and this idea of that globally there's this trend towards doing things more digitally. When it comes to simulation, typically we found that, or people seem to see themselves or see simulation as only being used in the sort of design phase of any design. So it typically comes in at the end and allows them just to kind of validate the design and see whether they're on the right track. But a lot of companies are finding that that's, or in two ways, they're saying that's not the only way they can use it, but we're also finding that that's not, it's almost too late in the design process. So in the sense that it can be used, simulation can be used in multiple different areas of the design process, of the whole product lifecycle. It's not only design, it can be used in manufacturing, looking at different manufacturing techniques, for example, like, there's been a lot of development in things like additive manufacturing and other new techniques. So it's about understanding the manufacturing process. It's about looking at the product's operational life cycle and seeing where we can make improvements there. And then also just looking at the actual service life of the product and how we can kind of predict the life cycle there. So for this example here, a big one is autonomous vehicles. To be able to validate and an autonomous vehicle design and make sure it's safe for use, that it would take something like 800,000 miles or something in 10,000 years to be able to drive that vehicle for that time, to validate it. But if we can do it all virtually, we can certainly cut down on that development time. Okay, so that's in terms of bringing simulation into different areas of a product lifestyle. But what we're also finding is that, bringing the design aspect of simulation into these later stages of product life cycle is not enough. We also need to bring it earlier into the design cycle. So this ideation phase, or sort of your concept design phase, there's a lot of emphasis now on bringing software earlier into the design phase. And that's where we'll talk about the Ansys Discovery product just now. So with this idea of the design cycle, this product life cycle, you'll see that obviously your concept design phase and your detailed design phase typically make up the smallest percentage of cost in terms of your product development. And obviously, as you go along, you kind of sink more cost into the development of that product. But what's really important is that as we get further down the line, if we find any defects or any issues with our design that we need to go back and change, that as we get further down this workflow, the cost to make those changes just grows almost exponentially. It becomes harder and harder to make those changes as we get further down the design cycle. So there's a real sort of emphasis to kind of go ahead of this. So typically, sorry, button there. So typically, most of our simulation work would be made at this detailed design phase, just finishing off the product, but that's almost too late to take on these or to identify these defects and change them. So we really need to bring simulation earlier into the design cycle and just sort of make it easier and quicker to use so we can reduce the impact of any design changes as we go along. Okay, and that's kind of where we're coming in with this relatively new product called Ansys Discovery. It's aimed at the design engineer to kind of aid them in the design of their products. So the idea of Ansys Discovery is a multiphysics tool. So it's about bringing together, or not actually bringing together, but it's offering lots of different physics that we would need for everyday products. So all your basic sort of simulation needs, well, for the average design engineer. So anything from basic structural and fluid analysis, even thermal analysis, as well as a relatively new one, topology optimization, which has really seen a lot of development now with things like additive manufacturing. So it's about bringing together all these different simulation techniques into one tool. And what's quite nice is it also has this option of a live physics simulation. So it's about getting you answers quickly and instantaneously, so you don't have to wait days and weeks for your simulation expert to get back to you. You can have your answers within an afternoon. But it's also allowing some sort of high fidelity simulation capabilities, as well as this option to clean up your geometry and do some CAD modeling as well. Because if you, for example, see any problems within your design and you need to update your design, you don't want to have to bounce back and forth between multiple products. You want to be able to do that all within one interface. Okay, so, and then also it's about linking also to our flagship products. So doing this initial design, initial simulation, and then taking it on to our flagship products for more detailed analysis. Okay, so within Ansys Discovery, we have these kind of three modes, if you want to call it that. So starting off in the model mode, this is focusing on our CAD generation and actual design of the components. So this is based on our Space Claim product that has been around for many years, and that Space Claim has been integrated within Discovery for that sort of making changes to the CAD models. Then we have our explore mode, which is, this is our live physics simulation, where in real time we will see our simulation results update. So in this example here, you can see we're making a change to this little duct here where we have our fluid flow. And just by making that instantaneous change there, or making that change, we can see that the flow updates instantaneously to that new design. Okay, so this way we can have great feedback between our design and any changes that we make. All right, we don't have to wait hours and weeks and all that for our answers. And then also from that, this is more of an exploratory stage, sort of almost like the engineer's 80-20 rule, where you get 80% of the results for 20% of the effort. I think this gets you a long way to your final design, but then you can take that design and refine it, where you have a bit more control over your basic settings, and like your mesh, for example. And these solvers are based on our flagship products, so Ansys Mechanical for FEA, Ansys Fluent for CFD. So you get a little bit more fidelity and accuracy in your terms of your results, and a few more, it also allows a few more detailed features as well. All right, so as I kind of mentioned or hinted at, Ansys Discovery is very much aimed at design engineers. It's about being simple, easy to use with a short learning curve, getting the results fairly quickly, if not instantaneously. So it's about reducing the cycle time of these of the design phase, and also basically allowing sort of almost an entry-level engineer, for lack of a better word, to access simulation and to be able to look at the results, make some design changes before having to hand it over to, say, a specialist in CFD or FEA that will take much longer to get the results, only to tell them that the design needs to be improved in some way. In terms of physics capabilities, it's covers all the, I'm not going to go through all these points, but just to highlight here that it covers all the basic everyday functionality that we would need from some sort of software package, obviously doing some basic structural analysis, some nonlinear models, topology optimization and all things like that. Fluids, you can do steady state, transient, laminar, turbulent, heat transfer, all of that kind of stuff. So it really covers a lot of everyday usage for a simulation package. And so sort of why we wanted to kind of bring this in today with this academic talk is because it's such an entry level tool, it's the barrier to entry is quite low. So it really allows a lot of opportunity for one to use it within maybe a classroom environment, or where you can do small projects. You just want to validate some sort of hand calculation, or just prove some sort of other theory that maybe is too complicated to do any other way. So it can really be, and because it's so easy to use and the results are fairly quick to get, the turnaround times are pretty quick, it makes sense to be able to use this in a classroom environment. And I guess the point here is it's not about replacing detailed simulations. So, I mean, this is not to necessarily replace your more standard sort of CFD classes or FEA classes and the work with the more traditional solvers. But this is for the students that aren't necessarily going to focus on FEA or CFD or anything like that. They just want to do a quick validation study of their design, that maybe they can't do experimental testing, or they couldn't see something from the experiment, and they just want to sort of confirm that they're in the right ballpark. They can use something like Discovery, get an answer fairly quickly, and then move on to the rest of their project. Okay, so this is sort of a supplementary tool, or can be seen as a supplementary tool to either your lecturing side and teaching side of things, or from the actual projects as well. Okay, so now we're just going to quickly move on to a little demonstration of Discovery, just so you can sort of see it in action and see what it's all about. So I'm just going to quickly switch over here. Right, so what we've got here is a little suspension system, so a double wishbone suspension of some sort of rally truck of some sort, sort of like one of those desert bar races, apparently. And so we're just going to do a little short FEA simulation on this, just to get a sense of what Discovery is and what it can do. So this is the interface that we see here. Let me just go out the way. All right, so as I said, this is all not only is a simulation package, but it's integrated into our SpaceClaim CAD package. So we can do anything from actual creating geometry and working with the CAD side of things, to setting up for simulation, and then actually setting our simulation results. Okay, and what we've got here in the middle, this is what I was talking about, our different modes that we're in. So at the moment we're setting up for, or this is in explore mode by default, which is not where I want to be for this tutorial. So I just want to move over to the next stage, the refine stage. So this is where we will use our flagship solvers in the background to do the calculations. And the only reason I'm really moving to refine for this demo is because I want to make use of a couple of extra joints in the operation or in the connection of these different components. And some of those joints are not available in the explore mode. Okay, so obviously explore gives you the instantaneous feedback, but some of the features are limited there. All right, so as we can see, we've got our suspension here, and we just want to do a couple of simplifications for the simulation work. So we've got these bolts here between our connections, which we don't really want to model them at the moment. We're not interested in that, so we can just click on them and remove them from simulation. So if I right-click on them, and I can exclude them from simulation. So now, even though visually we can see them as part of the design, they're not actually going to be included in the analysis. And you can see from our feature tree here on the left, which is listing all of our different components in the model, you can see that they've got this little red mark here, which basically means that they will be excluded from simulation. And then if also just click on the eye there, I will hide them as well, just to make life easier to work with the model. Then we've also got these 3 bolts down here, which I'm not going to worry about those guys either. So I can actually select them from the feature tree there, and I can exclude all of them from the simulation, and I can hide them as well. Okay, so that's just a nice quick way just to simplify the model and get rid of the components we do not need. All right, so now I'm going to set up some sort of fixtures and supports so that we can locate our model and start setting up our boundary conditions. So first up, I'm going to start setting up some supports here. So we're going to create some hinge supports on these bolt holes. So you can see that if I click on the geometry, it now brings up these little icons here, which they call this the HUD, the heads-up display. And this basically gives me quick access to all the major tools that I would need to work with the geometry. So in this case here, I haven't actually set up whether we're doing structural or fluid. So you'll see it offers me options for both there, but we're going to go structural, and I want to set up a support. So within the support option, we have a couple of different types of supports here. So obviously, this is now we're in refine mode, so I'll have a lot more options here. If we were in explore mode, this would be a bit more limited. So I want to go for a hinge support, and I'll accept that. And then I want to do the same to all these other bolt holes as well. And you can see that it actually remembers my selections from the previous time. So it actually just basically or nicely simplifies the setup and helps things go a little bit quicker. All right. We're also going to set up these guys here at the bottom. And we can actually just set them all up as a simple, also as a hinge support there. And now another boundary condition that we need is we can start putting our load onto the model. So we'll select this here, we're not going to obviously model all the detailed wheel and all that, but we will we will put our boundary condition there. So also, not only can we work through this little HUD, we can also go through our drop-down menu at the top. So there are multiple ways to access all the same information. So for example, here we're going to set up simply a force on those areas. Okay, and we can, you can see also here that it's all in yellow, so it's requiring some information. If I enter some information there, it's all green, and it's happy that we've given it all the information it needs. And you can see from the arrow, it's also giving us an indication of where that force is actually actuating along, and that force has just been assumed by the software based on our selection of the geometry. But if we want to have a little bit more control, we can actually go and edit these values as well. Okay, so I'm going to slightly change this to 1,000 newtons X. and we'll set this guy to 0 there. Okay, so once we've got all that information, we can just click exit out of there, and you'll see that now our force item has been moved to our feature tree over here. Okay. So what we also want to do is we're going to add some connections now. So this is between our different supports here, so between our different arms. So these joints are going to determine the interaction between these components. So we'll select our component there, go from the HUD, and we want to select a joint. Okay, so we've now selected our primary face. We can select on this little icon here to select our secondary surfaces. So I'm just going to select the other components from this upper wishbone here. There you are, looks like the right one. And we'll set that to a hinge joint. And then once I'm done with that, I can accept that. Okay, and then we're also going to go to the bottom here and create another one. Start right face there. Okay, so those are my primary faces. I'm now going to select my secondary faces. All right. So now I've selected my joints there. So that'll sort of set the orientation or sorry, the interaction between the different components. You can see also under the connections here, not only we got our joints, but we've also got a whole bunch of bonded contacts. So you can see by default, the software assumes that all interactions between or contacting surfaces are bonded contacts. Just obviously that's the simplest way to do it. But now we want to have a little bit more control over what's happening here and sort of customize it to be a bit more accurate. And you can see by double-clicking on the contact item there, it's highlighted all of our contact pairs that it's automatically identified. So what we want to do is now just go through all of these and just make sure that they are realistic. So we've got this quite a nice filtering tool over here for the contact items. If I select this guy here, I can select my primary object, select my secondary one, and you can see now it's highlighted which contact pairs are related to those two items. If I click on that little ball there, it actually selects this particular contact pair. So you can see it's highlighted in the pink and blue there. And obviously, if this was, if I wanted to keep this as a bonded contact, I could just leave it as is. Or if I want to change it, for example, to a sliding contact or some sort of joint or something like that, I can do that as well. In this case here, I'm just going to exclude it from contact detection because I'm assuming there's going to be no contact between those faces, and I don't need it to deal with them. All right, so again, going to have a look here at the lower wishbone. And I've selected my faces and it's shown me I've got this contact pair over here. So if I click on that, I'm going to do the same as for the top and exclude it from contact detection. All right, so you can see now here's still a few more. So we go to our arm. Okay, so we've got this interaction here between these two components. In this case, I do want it bonded, so I can always just leave it as a bonded connection or leave it as the default. But in this case, I'm just going to explicitly state that I do want it as bonded, just to be clear in terms of my design intention there. Okay. Okay, so let's have a look. What else do I need to do? So also, if I'm just going to leave this as a structural steel model. If I did want to, I can go through and select from our materials database. So we do have quite an extensive materials database here within Discovery. Also supplied, a lot of these materials are supplied by the Granta materials database as well. So it does link with that database. But for now, I'm just going to leave it as a structural steel analysis, or structural steel for this analysis. Yeah, I believe I've got everything. So let's go ahead and let's solve the model. So this little control area down here sort of controls all the post-processing as well as the actual solution of the model. Okay, so all my interactions through there. If I now have a look at this little information display here in the center at the bottom, you'll see that the yellow line around the edge here is now turning green. That gives me the idea of the status of the model in terms of how far it's along the solution process. Because we've now passed the halfway mark, I can actually go and display the mesh. All right, so the halfway mark is for the completion of the meshing stage of the model. So I can now have a look, and you can see here it's brought up the mesh. So this is automatically generated from the settings within Discovery. It picks up the design intent from all your boundary conditions and your joints and things like that. And you can see it's not a bad mesh for this initial study. It can maybe be refined in some areas, but you'll see it has done some automatic refinement around areas of high curvature like these bolt holes and other areas. So, but I think this will be good enough for an initial study, and we can see if there's any areas that we do need to sort of refine the mesh and for a better answer. Okay, so I think it just looks like it's done solving. We're just waiting for it to do some post-processing now. It always takes a little bit longer than you think when you're doing a live demo. All right, so here we go. Now it's done with the post-processing, and by default you can see it's showing me the displacement of the different components. So if I can actually go here from this little information or this little interaction area here, I can set to display my deformation, so I can see the deformation relative to my original unloaded body. And then I can actually animate that as well, just to get a feel for what's going on in terms of the deflection of this body. Okay, so let's actually turn that off. We'll go back to underform model and turn off the mesh. What we can also look at here is you can change, this is obviously displacement that it's been colored by. So we've got a few other basic items here on the list. So you can have a look, for example, the von Mises stress. And we can see that if we have a look at our design, there's a bit of a hot spot down here around this little radius. Okay, and if I hover my mouse cursor over this area, I can see in that little color legend on the right there, I can actually see the value underneath my mouse cursor. So just by hovering over there, I can see what kind of value I'm expecting and whether it's in an appropriate range or not. Okay, and what's quite nice is, yeah, you see within Discovery, you can also sort of have changed some of the ways you post-process things. So, for example, here, if I just want to have a look at the results just on this lower wishbone, I can click on there and I say show results only for this selection. So if I want to just focus my efforts on one area, then I can just select it out component by component. And just so, and this could also be quite nice for creating pictures for reports or something like that. If we have a look on the feature tree on the left here, you'll see that our lower arm has this little sort of rainbow colored circle that's showing that we are busy displaying results for that component. If I toggle that on and off, I can actually show results for the different components as well. So this way, just another way to actually interact with the model and show and get the information that I need. All right, so if we just go back and have a look at this model here, we can see that we've obviously got this area of high stress concentration, and we want to now make sure we refine it and capture what's going on in there correctly. So let's just get rid of all our results here and our mesh. And within the refine mode that we're working in now, we have this option to change the fidelity. Okay, this basically means that we have the option to do mesh refinement. Okay, so we're going to add a local mesh refinement in this region. So we're just going to select all these different surfaces in this area, and we'll do the same on the other side as well. Yeah, so now we've got those areas selected, and you can see here that it's popped up this little box. And for example, we can give it an idea of what's kind of mesh size that we're looking for. Okay, so this will be a target mesh size of 2 millimeters that I'll type in there. All right, and you can see here on the structure tree on the left that it's now added a mesh control setting. Okay, obviously if I've put more of them there, it'll group them together into a mesh item, but that's my local refinement. All right, the rest we can leave for now, so we don't need to do too much extra, so I can just go solve, and now it'll automatically remesh the model and solve it. Okay, so this is kind of I guess the difference between the explore and the refine mode, in the sense that we can have a little bit more control over our model with the refine mode. Okay, where with the explore mode, it's all done automatically behind the scenes, and so the user doesn't have to get involved at all. Okay, so we've passed halfway mark there on our progress bar. So if I click the mesh, I can see here now that it's refined those areas where I wanted it to, and it's left the rest of the mesh as essentially default. All right, also just a thing to note here, you can see this little bar here when I go over the refine bar. You can actually use this as a gauge for the overall global fidelity. So if I drag this bar more to the right, I'll have a much more refined mesh with more fidelity. Or if I go more to the left, it'll be a much coarser mesh for a much quicker solution. So I can also alter some of the global settings from there, and I don't even have to do any local settings if I don't wish to. All right, so it's really, the aim of Discovery is to take a lot of the work that would normally be done by the simulation engineer and do it automatically, just so that you can focus purely on the design and working with the design and the results. And yeah, so that's kind of the goal of it. But it is obviously based on all the sort of the correct, or all the knowledge that we built up from our flagship solves. Okay, so we're almost done there with the stage, just waiting for the results to be post-processed. So you can see for a fairly interesting design like this suspension system, within a couple of minutes we can return some answers. Okay, I'm running, I think, using 3 cores on my laptop to do this, so it's a pretty quick turnaround time. All right, so let's display the results for what we want on our lower arm there. It's obviously just trying to load all the additional results, the fine mesh. Okay, there we go. All right, so let's get rid of the mesh for easy to see our results. So if we go in here, you can see that we've still got our stress concentration around here, our areas of high stress. And we can see if we've refined that sufficiently. If we look up here on the top here, we've got this monitor table. So this is something that keeps track of our designs from one to the other. So in this sense, we've still stayed in the same design. We've just made some changes to the setup to see how it affects our results. So for example, here, if we look at the Max von Mises stress, you can see here that this is our initial design point. So even though we didn't set any design points, the software did recognize that we initially solved the model, we made some changes, and then we went to another simulation result. So it's kind of tracked some of these more common monitors for us, just so we can see how the model has changed. Okay, so we can see here that our von Mises stress has gone up slightly from by refining the mesh. So this is our max value. All right, so we can see that making that mesh refinement was necessary to get a better result. So we should actually do, for example, another mesh refinement iteration just to see if our values change again, and trying to find a mesh independent solution. Okay. I won't do that now as part of the demo, but at least this gives you the option to kind of keep track of how your simulation is changing with one change to the next. All right. There's everything to show for this model. One more thing to note, we obviously do have this export option here. So once you've done your quick models within Discovery, you can transfer them to our flagship solvers, and all of our simulation settings here, all our joints and boundary conditions and all that will be carried over, as well as our initial mesh would be carried through as well. And then we'll have the option to change that if we need to. All right. So that's our basic FEA simulation. I just want to quickly show another model as well, just because these are this will be quite a fun model to see. So obviously that was a more sort of traditional FEA simulation. What I'm going to show here is an example of a topology optimization problem. So this is one that is shipped with Discovery. Just as an example of the setup. So you can see here we have this bracket, some sort. It's actually quite a large bracket. So if we have a look at its dimensions, you can see here it's like almost like a meter in length. So this is quite a large guy here. See that it's been fixed at the bottom through these holes. So it's been connected somewhere there, and it's got two forces here on these upper lugs. Okay, so now obviously this is, as we said, this is quite a large component. It's going to be quite heavy. So we want to see if we can try and save some weight. So we want to run an optimization analysis. So here we're going to do, we want to make sure that our new component or optimized component has the maximum stiffness it can have. So we want to make sure that that is our design goal. We can also look for optimizing things for natural frequency or something like that. Okay, so we've got some other options in terms of how to focus our optimization goals. In this case, we're maximizing stiffness by doing it by, and we're going to be reducing our volume as part of the analysis. So we can also set that. So we want to try and target losing 50% of our volume. So maybe hopefully get to half of our mass of the original component. And you can see here we've also got this protected distance, and that's what's highlighted around these different eyes here. So this basically just means that we're keeping the material around these attachment points so that you know, we obviously, because this is where the component's going to be attached to some other component, and we want to make sure we've got enough material there for, say, a bolt or something like that to connect All right, so that's our setup there. If I go solve, so you can see here topology optimization, we're running in the explore mode. So this is now running on our sort of instantaneous feedback here. So you can see every time it does an iteration, it will update the results and show it to us as soon as it can. All right, so you can see with the topology optimization, basically what it's doing is loading the structure, seeing which of the mesh cells are carrying the most load, and then removing the cells that aren't really doing anything or contributing to the overall behavioral or structural stiffness of the model. Okay, so you can see here it's busy eating away all over the place. All right, so this is technology that's been around for some time, but it's really come to the fore recently due to interest in techniques like additive manufacturing, where we can actually 3D print these type of sort of organic components. Okay, something that hasn't typically been possible before. All right, so if we leave this running, it'll just keep sort of optimizing. It'll eventually stop once it reaches the target goals that we set. I don't actually want to bore you guys and take too long, so I'm just going to pause that. All right, and you can see now we can have a look at our model, look at the stress in there and see how this component is performing. All right, and what's quite nice about this, so I can now isolate so this is the faceted body. So you can see all these triangulations here. This is the faceted body of our new optimized shape. And you can see it's actually created a faceted item in the window here. All right. So so this will be our optimized shape. Obviously, it looks a bit rough and messy. So we can actually go and smooth that design as well, just to make it a little bit cleaner and neater, either for printing or just for use somewhere else. So you can see there that's a little bit nice and easy to work with. And what we can actually do is even convert this to a solid body. So at the moment, this is a faceted STL geometry, which it's a valid geometry file, but it's not necessarily the most convenient to work with. So what it's doing now is just basically creating a surface map of all those different triangulations and converting it to a solid model that is a little bit more convenient to work with in terms of the geometry. So it does black out a little bit like this. So it's just busy thinking in the background. There we go. Okay, and you can see it from the progress bar that it's almost done converting there. Okay, so after all of that, you can see now we're left with a part that is a much neater, cleaner model. So these are actual geometry surfaces or spline surfaces and that describe the shape of this part. But this is something that is much easier to work with. You can now go take these edges, clean them off, extrude them, cut holes in them, do things like that, something that you wouldn't have been able to do very easily with the faceted body. So you can actually take this part and use it in an assembly in some sort of other CAD model. Okay, so now that's quite a nice, easy way to work with these optimized components. So this is quite a nice, useful for discovery and something that's really worth playing around with if you guys get the time for that. All right, that's enough of our demo. There's a lot more to show, but I think for now we'll just get back to the presentation. Okay. So moving on now, we're going to start focusing on what the different offerings that Ansys has for academic institutions. And I think, yeah, something that's kind of prompting this and something that it's really important to keep in touch with is this idea of, from the commercial sector, there's a huge move to digital technologies, particularly simulation. It's something we're seeing quite massively overseas, and not pointing fingers here, but the survey was done a couple of years ago to say that at least institutions in America are not sort of keeping up with these trends and not keeping touch with them. And so it's just, I think, again, just the purpose of today is to make you guys aware of what's out there and what are some of the trends going on around the world, and just making sure that everyone is up to date with what's happening. Okay, and to that end, Ansys is, well, they've always had a very close partnership with academic institutions in terms of not only from the software side, but also various partnerships in terms of research grants and things like that. So we'll touch on a few of these now. This slide's more just for the numbers, just to show that, back up the fact that they have a very close partnership with many institutions all over the world, and they have a real vested interest in academia and partnering with academia. And I guess for us, we just want to thank you guys for being part of this program. You are part of these numbers, and in terms of working with us and Ansys, and providing these options for your students. So in terms of at least the software offerings for the academic sort of arena, most of you would probably be most familiar with the Multiphysics campus license, whether you kind of know it or not. Most of the different institutions have this kind of licensing system. And basically what this is it's a pool of licenses for the different solvers. So your CFD, your FEA, electronics, all of those kind of typical packages. And it basically gives you a whole pool of licenses that you can access on demand. So the idea is that this research group doesn't need 10 licenses and that one needs 5, and and then you never use them half the time. It's about having this dynamic pool of licenses that, as you need them, you can just draw from them, and then when you're done with them, they go back into the pool for someone else to use. So it just makes for a much more sort of efficient use of the licenses. So you get more sort of bang for buck, and also, it's this way. Each group can kind of contribute to the overall cost of the licenses, but it's split up much more efficiently. Okay, and then something just to make you guys all aware of is these campus license bundles are broken up into research and teaching licenses. So the research licenses are your full solvers, all the features, no restrictions, whatever. So the same as you get in the commercial sector. And that's obviously intended for your postgrads and your lecturers and that to do all their research work with them. But then they also have a whole bunch of teaching licenses that come with that bundle. And as far as I know, they're not limited in terms of features, but they are limited in terms of the size of the models you work with. Okay, and the intention behind these licenses is that you can access them in a classroom environment. If you're running a small project within the class, students can use these licenses instead for that small project, and they're not eating up valuable licenses for the researchers doing all their work. Okay, and depending on which level you have, you will obviously get more licenses for each of those levels. Okay, so obviously this will depend on your usage. The more you use, the more or the more you need, then you'll obviously need to move to the next level there. All right, and then also an offering that's been around for some time is this idea of the student versions. So we do offer student versions for most of our products. And the idea with this is kind of like the teaching licenses where, there's no sort of limit on the features, but there is a limit on the size of the model. Okay, and the idea is that this is a software that a student can download themselves. There's no requirement for licenses, so they can work from home or wherever on their projects, and they don't have to be tied to connecting to the license server on campus. So we've had that issue a little bit over the last year where students can't always access the license from home, but then they can make use of the student version to do their work. Okay, the only, I guess, the other big thing to note is obviously the student version is not compatible with the research licenses and the commercial licenses. So whatever project or model you develop in that version, it cannot be transferred to the other ones and vice versa. Okay, so obviously just making sure that commercial users can't make use of the student version for their work. All right, and as mentioned, we've got our student versions, our basic FEA CFD packages, and then quite a new addition to this is the Discovery student version. So that's also why we were showing you the Discovery product today, is there is a student version of that available that students can use. So it can be quite a sort of powerful tool for the students to work on at home or wherever they might be based. Then also LS Dyna, there's a student version for that. Some of you may know LS Dyna or be familiar with LS Dyna as a FEA package and other simulation package offerings as well. For those of you who don't know, LS Dyna now falls under the Ansys portfolio. I think it was sometime last year, beginning of last year, I think that they now fall under the Ansys portfolio. So we offer the student version for that as well. And then the SCADE suite as well as a student version. So this is for those anyone doing some sort of embedded control programming or control software. You can actually use SCADE to develop the control software for your different components, and it's to also have it all certified code as well. So this is quite a powerful offering there. Then also something that's maybe a bit underutilized, but is also very useful is the Ansys Learning Forum. So this is an open forum for anyone to go and ask questions. They will get help either from other users or from Ansys technicians as well. So the idea is, and this is really, I think we always try and point the students here as sort of the first point of call or point of reference, so that, in some cases, their questions might even be answered on the forums already, and they can get that information there. It's available to them. If you just do a quick Google search, and you'll find it. And if it's not there, then they can even ask the question and hopefully get an answer from that. And then at least other people can learn from those questions as well, because that information is free to access. Where if you access or trying to ask a question to us, our platform is not freely available. So this is always trying to encourage students to make use of this forum to try and find out the answers to their questions and maybe help others learn as well. Okay, so this can be accessed from ansys.com/forum. Okay, and as I said, all the topics are available. If you just do a Google search and it's there, it'll probably come up. All right, something that's relatively new that's come about sometime last year, and I think it's really exciting and will be hopefully very useful for you guys. Is what Ansys calls the innovation courses. So this is a whole bunch of online courses that Ansys has developed, covering topics, or sort of obviously engineering related topics of different physics relating to simulation software as well. And kind of merging all of that together. And the idea is it's there as kind of an additional support tool for not necessarily only academia, but anyone who wants to learn about engineering, wants to learn more about simulation, maybe topics that they haven't done before. So this is a free online curriculum that they've put up there. I don't think you get any certificates or anything from it, but it's just information there that's free to access and to make use of. So we can actually just have a look at that here. So this is the web page here, so courses.ansys.com. If you come here and you scroll down, you'll see that they have different options for the different physics. So there's fluid, structures, even light-based. There are products, numerical there, materials engineering, electronics. So it's quite a wide range of different courses that are on offer. So let's have a look here. For example, the shock expansion theory. So if we now have a look at that, they've got information. So here's different sort of lessons, obviously guiding from the basic introduction into sort of more detailed knowledge of that. And you can see that they sort of now obviously expose information and videos and images and all that to cover these topics. All right, so this is something that's fairly new, very powerful, and Ansys is adding to it all the time. And it's just something we want to make you guys aware of, especially these COVID times where everyone's working from home, and maybe students need some sort of supplemental information that they can get access to and kind of learn in their own time. This information is all there available to them, and it's all free to access. So it's just something to make you guys aware of. You can maybe share it with your students, and just it's just another portal for information. Okay, and then also something that's been around for a while, which hopefully you guys do know about, and I know some of you are making use of this. This idea of sponsorships for student competitions. So obviously there's lots of competitions all over the world, all over the country, and Ansys really likes to sponsor teams that are working within these different competitions, providing them with the software simulation resources they need to do the analysis of their designs, because obviously some of these different competitions get very competitive, and obviously simulation can help work or prove the designs and give them that edge. And I don't know if they necessarily part too much with hard cash, but they certainly do give sponsorship in terms of software and other resources to the student teams. So if you guys are partaking in any of these challenges or any official competition this is just a short list of what can be there, but there's a whole bunch of other ones. If you are partaking in any competition, reach out to us and let us know if you'd like some sort of sponsorship. I think the only real requirement is that you just put an Ansys sticker somewhere on your vehicle or equipment, maybe do a little blog article or something, and so it's quite a nice sort of opportunity there for students. And then also something that's relatively new, although some of you are making use of this already, is this Grantor EduPack. So for those of you who aren't aware, the Grantor materials is a materials database that's been around for some years, and that also now falls under the Ansys portfolio. And it's not, as a software, it's not just a materials database, it's also software that can be used to select and compare different materials. And then what Grantor have done is, in addition to the software package, they've providing all these teaching and learning resources. So it's almost creating like a little materials course to go with the software. So students can kind of learn about material selection and material science while making use of the software. So for example, this is sort of a typical screenshot from Grantor. So in this case here, we're looking at plotting all the different types of materials in the database based on their yield strength as well as their carbon footprint. Okay, so this is just not comparing, strength and weight and some of the engineering properties. It's looking at a lot of other criteria as well. So these days your lifecycle assessment with your looking at greener materials. You know, we can actually compare that to the sort of typical engineering values like yield strength, so we can make sure that our materials fit for purpose, as well as also on the green as it can be. So this is kind of the power of the granted database. It's not just a listed database, it's giving you these tools to compare materials, look at how they perform relative to each other. There's also cost parameters and things you can add in there. And so in addition to the software, there's the whole EduPack, which gives you actually a bit of a structured curriculum about material selection and things like that. So I know some of the institutions in South Africa, some of the universities are making use of it. So if anyone who's not making use of it, you're welcome to get hold of us and ask if you have any more questions about that and how you can get hold of that. All right, so I think that pretty much covers it for this presentation or this webinar. So we've looked at the product Ansys Discovery, that it's this quick, easy to use software. You know, it's a nice entry-level product for those who don't necessarily have the time to specialize in simulation, you know, because they just maybe want to supplement their design project, or you know, want to do a quick project in class or something like that. So it's not necessarily there to replace the rigorous simulation that we would normally do and to get rid of all that technical knowledge, but it might find a niche in some applications. And then we've also looked at a couple of the different offerings from Ansys about in the academic arena, looking at software bundles, student versions, looking at the online materials and the forums, which are free to access. So it's another sort of additional learning tool that can be used. And then we saw also the Grant EduPack focusing more on materials, as well as adding some sort of educational component to that as well. Okay, so thanks guys for your time and your attention. Just to make you aware, just last point from me is our next release of the software is coming out end of this month. It will be available, so just make sure that you know, your IT support, whoever takes charge of the downloading these new versions, is aware that it will be out end of the month for you guys to access. Great, thanks guys, thanks for your time, and if there's any questions, please either in the chat or you can unmute yourself as well. I can thank Lara.
Yes, thanks a lot, Evan. That was very thorough, and I'm sure everybody enjoyed that a lot. There's a lot of tips and some lessons and some key takeaways that these attendees can take back to the universities. So is there any questions from anybody at this stage with regards to what we presented? Yes, Garnet, you're welcome to ask.
Hi, Dr. Evan, and thanks, Laura. Just a question, the Ansys Discovery, does it work with all the composite materials as well, or is it limited to that?
No, unfortunately, it doesn't work with composites. It's for your sort of more traditional homogeneous materials.
Okay, now that's all I wanted to know.
Yeah, no, with the composite materials, it's as you've seen yourself, that there's quite a lot of work in terms of the pre-processing to lay out all the different layers of the fiber orientations and all of that. So it's not really kind of geared or intended for that kind of market.
Okay, no, perfect. Thanks, Dr. Smith.
Okay, there's a question in the chat. Is the AM lessons included?
So that's for the additive manufacturing.
Yeah.
So there are some tools for within the Space Game Discovery for setting up all the additive manufacturing features, like the supports and things like that. So it is kind of geared to additive manufacturing. I'm not sure what you mean by lessons. We can do some training on that if you want to specifically use it for additive manufacturing. I don't think there's anything in the Ansys Learning online for additive manufacturing. Let's have a look.
Yeah, I think Dr. Malika thinks she's saying the course is on the course.ansys.
Yeah, no,
So
I haven't seen
online
anything
learning
on
courses.
additive manufacturing yet.
Yeah. But it's something we can take away and just see if there's something else that we can share with you, okay?
Yeah, there's certainly other Ansys learning material around additive manufacturing.
So we'll take that as a takeaway and we'll send it to you, okay? So there's another question, Dr. Kukwa. You are welcome to ask your question.
Yes. Yeah. Is it possible to run a CFD with the discovery model?
Yes, yeah. Unfortunately, we didn't have time to share everything, but CFD, so your basic, you know, you can do steady state, transient, turbulent flow. I think at the moment it's only single phase, but they are in the next couple of versions they are bringing out not necessarily multi-phase, but in terms of like free surface or anything, but just other material interactions and all of that. Sorry, I'm just trying to find, there is a slide on the physics capabilities here. Yeah, so, and then obviously things like porous media and all of that will be coming out, and non-Newtonian fluids are in development, so they will come out soon.
Okay, thank you.
Pleasure. Any other questions from anybody at this stage? Evan, thank you very much. It doesn't look as if there's any questions. Thanks for attending. We will be sharing the recording afterwards, and then you are welcome to contact either myself or Evan if you do have any questions at a later stage.
Sure, and I mean, as always, if you guys have any questions, we do have support at